Okay, so when you look at your lighthouse angle of depression, we realize that because you have an angle of depression here, it's going to be equal to your angle of elevation of bottom because of parallel lines, your alternate interior angles. So if we kind of isolate the triangle that we want, one of the things in a word problem is that sometimes the extra stuff can be really confusing. So extract out just the part you want to work on, right? So I kind of pull this out. I'm going to write down the parts that I'm looking at. This part I don't need to do, but it is your alternate interior angles to get you that, right? So you're looking at a right triangle. You've got opposite, you've got adjacent, you've got this angle. It's a clear tangent question, right? And you'll find that's actually fairly common in this kind of problem. So I set it up. You can treat tangent of 6 degrees over 1. You can cross multiply. You're eventually going to get this equation here. And then at that point, it's just a calculator function, right? 130 divided by tan of 6 gives you that 1,236.9 feet away from the lighthouse. Okay, this is what you would consider a pretty straightforward level 1 type of word problem application for trig functions. So this one's level 2. So let me just explain it. Again, you have angles of elevation, angles of depression, right? Those are the same kind of scenarios as before. We need to set up 2 equations. Okay, take a minute and see if you can write out the equations here. So in order to do this question, it's asking me to figure out how far did the car travel from here to here, right? What is the distance x? And you can notice you have the 2 triangles. The smaller triangle here, that's the first one. That's the one I can actually solve to start with. And then I have this larger triangle here that has a combination of the x and the d. So I'm going to have to write out my sides that look just like this. When we solve the first one, obviously we're going to find d first, right? I can go ahead and just like before, I can take my trig function and solve that for d by doing this computation, 100 divided by tangent of 46. Now, of course, you could have found the other angle up top and worked with it that way as well. I didn't feel I needed to do that, right? So you should get 96.57 feet for d. Now, I'm going to work the same thing, but x plus d is equal to 100 divided by tangent of 22. So we'll solve this last equation. I'm going to get x plus d, right? I'm going to get the total distance. What I'm really interested in is getting just x. So how do we get x from these 2 numbers? Because one is the total distance and one is the shorter distance d. How are we going to get the other 2? We're going to subtract because I really like to know what's the difference in the 2 groups, right? That's x, right? So 247.51 minus 96.57, which gives us, what did you say it was? 150.9. And the answer is? 150.94 feet. 150.9 is fine. Okay? 2-step, well, really it's 3 steps, right? You had to solve each of the little trig functions first, and then you had to figure out, okay, those aren't technically either one what I wanted, so I have to subtract the 2 because I wanted the difference in the 2 groups. Any questions about that? I would consider this kind of like in between. It's not super hard. It's not super easy because there's quite a few steps to it, right? But it's more a longer problem than it is a difficult problem, right? So think about steps along the way. As long as those steps are relatively straightforward, I don't mind doing that kind of problem. It's the ones that are conceptually hard to put together that would consider difficult. We're going to create 2 equations. Just like last time with the cars. Can you write out these equations? I'm going to write down my triangles first, and then I'm going to write the equations for those triangles. So the first one is the small one. You can see that here, right? It's 48 degrees with x as the horizontal and h as the vertical. And this one is going to be 40 degrees with x plus 10 and the height of h. Correct. So if we're going to write out our equations, it's just the tangent functions because you have opposite and adjacent sides or have something about them. But the problem here is I now have 2 unknown values. That's not so good. We're going to have to do something that you haven't done in a long time. We have to use a system of equations we called substitution. We're going to solve the first equation for h, and we're going to do that by taking this x, and we're going to multiply both sides by x, and so we're going to get h equals x times tangent of 48. Okay, so I have an h here, and I have an h here. I'm going to take this, I'm going to plug in for this h. I'm going to rewrite that equation here. My goal is to get an equation with just x. No h's, just x. If I can get an equation with just x's, I can solve that. I can only solve for one missing thing, but not two. So we use substitution to kind of work this out. We're going to solve this equation for x. Okay? Now, see, this piece is what we substituted in. We just plugged that value in for our h. We're going to treat this like it's tangent of 40 over 1, and I'm going to cross multiply. So we're going to get x plus 10 times tangent of 40, and then 1 times x times tangent of 48. So I'm going to get rid of my fraction, because I don't like to work with fractions like this. I need to get them outside of the fraction. So we're going to cross multiply, and we're going to end up with an equation that looks like this. I'm going to need to distribute here. And if you want to, it might be helpful at this point to, instead of writing tangent of 40 and tangent of 48, I could convert these values into decimals. Right? I'm going to do that in the next step. Okay? But just to show you what's going to happen, we're going to multiply tangent of 40 times x, tangent of 40 times 10. I'm just distributing this value, and then obviously that one just because it's going to come down. The next part, I'm going to take these tangent of 40s or 48s, and I'm going to replace those with a 4-point decimal equivalent, right? I want to try to keep it as accurate as possible. And so 4 decimal places is more than enough. If I were going to round to 2 places, I want to keep more than 2 in my work. And so I'm going to put all these values into the calculator and get their decimal equivalents. And then I'm going to write that out. And then it's going to look more like an algebra problem than it would be a trig problem. And really that's the trig part of this, we finished a long time ago. When we wrote the tangent down and got the equations, we were done with the trig. Right? Now it's all algebra. So I'm going to replace these, and you're going to see now that, oh, it's just combining like terms and then dividing. Right? So we replaced these. I went to 4 decimal places all the way around. And then you can see here you have an x times, so 0.8391x. And 1.1106x. So I'm going to subtract this value from both sides. And I'm going to multiply this one times 10. And then we'll see what we get. So obviously multiplying by 10, you're just going to move a decimal place. You're going to get 10.8391 equal to 0.2715x. I'm going to divide, the last step is to divide by this decimal point. And we're going to get, now be careful. What are we finding? Look at my picture.
The height of the...
Oh, that's the question, but am I finding that right now?
No.
What's x going to be?
Yeah, what's x?
X is just the distance that first line is away from the base right underneath the thing, right? So when I go to write out this equation, or this answer, technically I haven't really finished the problem yet. I'm almost there. I mean, the next step is super easy. But a lot of us may be tempted to leave the answer, oh, it's 30.91. Well, yeah, that's a good answer, and you're definitely going to get some points for that, but you're not quite finished yet. How tall is it? Well, do we have a formula for h? Guess what? We do, right here. H is equal to x, which we found here, times tangent of 48. So we're just going to plug that in and get out my solution. Piece of cake. So the actual helium balloon is 34.33 feet off the ground. So here's the setup for this question. You are out hiking with a friend, and you guys look up and you see a mountain in the distance. You're curious on how high the mountain is from where you are. And so you can find the elevation by doing a few things. Number one, you measure from where you're standing the angle that you have to look up, right? And so you figure out that it's actually 46 degrees for you to go from your horizontal all the way up to looking at the very peak of the mountain. You take your friend walks 1,000 feet in front of you on a flat level ground, and they do the same thing. And they look up, and they have to look up a little bit higher because they're closer to the mountain, and so they look up at 48 degrees. The question is, how tall is the mountain here? And so what you do is you know that you have 1,000 feet between the two measurements. The distance from where your friend measures the angle to the center, like the height of the mountain where the base is, that is x. All right, we're going to call the height of the mountain just h. So the question is, how tall is the mountain? If you've done the question just previously, then you know exactly how to set this up. Take a few minutes and then pause the video and then go, try it on your own, and then I'll explain how we did it. Okay, so here's the full explanation. Here's the miniature version of the picture, and we have this kind of setup. We walk it through the exact same setups, right? So we're going to draw our two triangles and write out the two equations. We decide to take the shorter of the equations and solve it for h. We plug this into the h over here, right? We're using substitution. And so we have tangent of 41 right here equals the part where we substituted the x times tan 48 over the 1,000 plus x, or the x plus 1,000. Here we're going to cross multiply. This is like over 1, so we multiply both sides. We're going to combine our like terms. Now at this stage, I turned all the tangents of 41s or tangents of 48s, I turned them into decimals, and then combine my like terms, and we're going to get this. So 1,000 times tangent of 41 is 869.29. And when you do the tangent of 48 minus the tangent of 41, you get 0.2413 times x, because x is here. I'm going to divide at this point, right? We're going to divide the tube out. We're going to get a value of 3,601.3 feet. That's how far you are from the base of the mountain. That wasn't the answer to the question, because the answer to the question was how tall is the mountain, right? So we're going to have to take our distance here, x, and we're going to go back up to this equation, right? We have an equation that's equal to h based on x. So we're going to plug x in. We're going to multiply through. Turns out the mountain is about 4,000 feet tall, 399.7 feet, right? If you can do this question, right, from start to finish, if you can work your way through that, it's a very similar question to the one we did before. You should feel pretty confident that in terms of like the harder questions, I think this is one of our harder questions for this unit. I think you're going to be in really good shape. So if you got any questions, please feel free to email me or let me know in class, and I'll be happy to answer your questions.